Morning students, welcome to Analog Circuits video lectures. This Analog Circuits subject is extension of electronic devices and circuits. In previous semester, you have studied the electronic devices and circuits. In that, you studied the electronic devices like diodes, BJT, MOSFET, photodiode, pin diode, or photoelectronic devices. In these analog circuits, we will study the major applications of electron device like diode applications, BJT applications, MOSFET applications. In this analog circuits, we will study the analysis of circuits. Next, we will deeply discuss. It is divided into 5 chapters. In this first chapter, we will discuss the diode applications like clippers, clampers, and other applications. The major application of diode is rectifier. We already discussed in the previous semester. In this semester, we will discuss the other applications such as clippers and clamper circuits. In this first chapter, we will discuss the small signal analysis of amplifier models. We know the major application of BJT or transistor is amplifier. In this Unit 1 or Chapter 1, we will discuss the small signal analysis of amplifier models. In that, common emitter, common base, common collector, or in MOSFET, common source, common drain, and common gate. In Chapter 2, we will discuss the high frequency analysis of amplifier models, again like CBCECC, and in MOSFET, common source, common drain, and common gate. Along this, we will discuss the different power amplifiers that are Class A, Class B, Class C, and Class AB power amplifiers and their efficiency. Next, we will discuss the feedback amplifiers. In this feedback amplifiers, we will study the different topologies like voltage series, current series, and voltage shunt and current shunt, and the effect of feedback on gain, bandwidth, different parameters. In third chapter, we will discuss about the oscillators. In these oscillators, we study the basic concepts of oscillators like Barkhausen criteria and different types of oscillators such as RC oscillators, LC oscillators, and non-sinusoidal oscillators. In the fourth chapter, we will discuss the operation amplifier and its applications like logarithmic amplifier, multipliers, comparators, detectors, schematic, and etc. In this chapter, we'll discuss the active filter design. That means designing of low pass, high pass, band pass, and band stop filters using active elements. In the last chapter, we'll discuss about the analog to digital converter and digital to analog converter. In the analog to digital converter, we'll discuss the single slope, dual slope, successive approximation, and flash type ADC. In digital to analog, we'll discuss about the weighted resistor, R2R ladder, and resistor string, etc. This is about the syllabus of analog circuits. Textbooks and reference books of the analog circuits. So you can go through the following textbooks for the required content. First, will prefer electron device and circuits theory, Boylsted. So the same book is given in EDC subject also. Next book, Microelectronic Circuits and Theory, Sadran Smith. Then after EDC by Millman Hawkins. For the operational amplifiers, you can go through the Gaikwad and Ramakant, and you can go through the given reference books also. For the video content, for NPTEL videos, you can go through the analog circuits by Professor Nagendra Krishnapura, IIT Madras, and here I mentioned the web link also, or video link. First, we'll know the what is analog electron circuit or analog circuit. An electron circuit which can process the analog signal. Digital circuit means which can process the digital signal. Otherwise, you can say a circuit whose input and output signals are analog, then that circuit is called analog circuit. So in previous semester we studied the diode applications. In that rectifiers, we are applying the input signal is analog and output signal is also analog. So we can say the examples for the analog circuit is rectifier. Similarly, amplifier also. Amplifier is nothing but it increases the strength of the signal without changing the shape of the signal. Yes. So the amplifier input is analog and output is also analog. So we can say amplifier, rectifiers, and that's it. Are the examples for the analog circuits. What are the advantages of analog circuits? Nowadays, everything is digital. Even we are using the digital circuits, we had limits in the digital circuits. That limits in the digital circuits are disadvantages in the digital circuits will become the advantage of analog circuits. So in our real life, the majority of the signals are analog signals. Hence, they can be directly processed in the analog circuit. In digital signal processing, we require the analog to digital converter and digital to analog converter. Yes. Then what happens? In digital signal processing, we require the ADC and DAC, ADC and DAC. Due to that, complexity will be increases and the signal accuracy will be decreases. When we are converting from analog to digital or digital to analog, we are taking the samples. That means the accuracy of signal is lost. So the advantage of analog circuit is the first one. In real life, every signal is analog signal, so we can directly process in the analog circuits. In digital signal processing or digital processing, we require analog to digital and digital to analog conversion circuits, which increase the complexity of the circuit, and in digital signal processing we lost the signal accuracy. Yes. So this is the advantage of analog circuits. And analog circuits can process greater or higher power signals. It is also one of the major advantage of analog circuits. Yes, this is about the introduction of analog circuits subject. In next class, we'll discuss the diode applications. Then after, small signal analysis of amplifier models. Thank you.